Hello, this is the second of two videos for the very first module in Weather and Climate Geography 306. And we're going to take a quick look at the idea of a system in science and how we study systems. Now, we're not going to constantly return to this specific approach word for word, but it gives you a sense of how scientists approach trying to understand a complex world. So in your notes, again, that you have access to, my first questions are, what is a system and how do we study it? Well, first of all, in nature, really, a system is virtually anything that you can draw a line around. So I often use Lake Tahoe with my students, even though that's not specifically weather related, as an example of a system. It's very clear what defines Lake Tahoe, that big dent in Earth with filled up with water. Other classic systems, we might study a big, beautiful thunderhead and try to understand what is happening to that. Or Earth itself. I often speak about the Earth atmosphere system. And again, our focus in this class is on the atmosphere itself, that layer of gases surrounding Earth. So when we try to attack the question of how do we study systems, one of the first things is we try to understand what goes in and out of the system. To get a handle on how it works, we look at the energy that goes in and out. So maybe there is solar radiation or long wave radiation, often called infrared, that gets in or out of a system. And we look at matter, whether matter, stuff, substance gets in or out of a system. Now, matter really is, again, anything of substance, even invisible water vapor or just air is also matter, just like dust would be, just like in Lake Tahoe, a fish would be. Throw a big rock in the lake. That's easy to consider inputs of matter. Pull some sand out of the lake, that would be outputs of matter. Pull a cup of water out of the lake, that would be outputs of matter. So studying a system requires studying the inputs and outputs of matter and energy. And we're gonna continually do this. It also then requires us to study what happens within the system. But again, this is just a good way for our brains to get a handle on things. In nature, when we're studying systems, we're looking at all of the biological components that make up a system, the plants and the animals, the living stuff, and the abiotic components, the non-living stuff. So that would be rocks, minerals, atmosphere, and so forth. One of the things we do, again, to try to break these concepts down is to break them into smaller bits. When we study Earth, we look at what's called its spheres or I like to call them subsystems. If you look at the entire Earth atmosphere system, it's really more appropriate to see them as made up of these four spheres. So the atmosphere is the layer of gases that is approximately 300 miles tall. That's a really good little fact for someone in a climate and weather class to remember. 300 miles tall or 500 kilometers tall. By the time you get out beyond that zone, there's virtually no atmosphere left. Maybe like just a molecule of nitrogen, and then 20 yards away, another molecule of nitrogen. That's basically nothing. So that's why 300 miles is a good round number. So again, we look at what it's made of, which we will do in detail, and we look at how it moves and how it functions. We look at inputs and outputs. The hydrosphere, all of the water that makes up Earth. And frankly, weather and climate cannot be studied without looking very closely at both the atmosphere and the hydrosphere. These are two incredibly key subsystems that essentially generate most of our weather. The lithosphere, the solid, hard, rocky portion of the Earth. And we're going to spend less time on this in weather and climate. In other geography classes like physical geography, you should know if you become interested in geography, many of you may have already taken physical geography, we really try to give equal treatment and look at all of these spheres together and then look at how they interact, to look at how the lithosphere interacts with the atmosphere and the hydrosphere and so forth. But we will spend less time. There'll be some necessary times when we look at the lithosphere. And then the biosphere, what my professor, when I first took a geography class in the early 80s in ancient times, she referred to this as the veil of life surrounding Earth. And I have never forgotten that term. It's really an amazing thought. And so we will, out of necessity, look at the biosphere as well. And then, ultimately, really true geography, when we want to look at Earth's systems, we often do look at all of these together. It's very, as I say here, it's a complex undertaking to try to study Earth systems or study the entire Earth atmosphere system. But a couple of kind of classic examples, just in a photograph, if we go to the coast and we want to try to understand what some people might call the coastal interface, the land-ocean interface, we see the coming together, the overlapping of all of those four subsystems we just talked about. The atmosphere, and notice all of the air woven into this, the spraying of the water, the hydrosphere, the solid, hard, rocky part of the coast, the lithosphere. And then, of course, if we were to start going in and studying all of the creatures here, the plants and the animals, that would be the biosphere. And so it is often a complex, dynamic set of relationships and interrelationships, how one thing affects another. And then, of course, important to us is something that is commonly called the hydrologic cycle, studying the movement of water throughout the entire Earth atmosphere system. It simply cannot be looked at in isolation. You have to, when you're studying water and the movement of water, you, of course, have to study the oceans, which is one of the things we're going to do. But then you have to study that connection to the atmosphere, because water, for part of its life cycle, so to speak, for part of its existence on Earth, is in a gaseous form, is essentially in an atmospheric form, water vapor. So, you can see the clear interrelationships between the hydrosphere and the atmosphere here. But also, what about the lithosphere? Well, certainly water falls down onto land all over the world, and it soaks deep down beneath the land and passes beneath. We will spend certainly less time on this lithosphere portion in this class, if we do at all. And then also the biosphere. A great deal of water passes into plants and then out of plants, and that has a significant impact, which will become apparent, especially when we talk about climate around the world, patterns that are repeated of temperature and precipitation over long periods of time. One of the things we do is we look at the type of plants and animals that exist in those locations to try to help us get a more visceral understanding of climate patterns, long-term averages. So that concludes really our first introductory module. We will have two introductory modules, but this concludes really part one of the introduction to weather and climate. Again, I thank you for your valuable time. I urge you one way or another to get access to these notes so that you have them with you and available. All right, thank you so much. And we will see you in the future.